We will start part 2 with Python language basics. First of all, what exactly is GeoPy? We have seen and run Python macros and even added a variable, but apparently we did not really mention GeoPy. GeoPy is an interpreter for Python 3.6, so that any regular Python script should run in GeoDict. However, GeoPy gives access to GeoDict-specific functions. They are called the GeoPy Application Program Interface, short API. An API is a set of commands, functions, protocols, and objects that programmers can use to create software or interact with an external system. The GeoDict API commands all can be recognized by the prefix GD. In fact, we have already seen a GeoDict-specific function. The gd.run command that is used to run the commands which are saved from the user interface. We used it to generate a fiber structure. To start with Python, we suggest to record a Python macro in GeoDict, as we have done together, and then we can use variables and macro for parameter studies. But now in the following, we show you some useful Python language basics. They will help you to make parametric macros even more useful. I will type them together with you in the editor. So open the editor again and open a new file with File, New. We will save this file as output.py, and therefore we click on Save and enter output.py. Again, make sure that it appears in your project folder and that the right file type is selected. The first Python basic function I will show you is text output, which can be very useful for debugging. Imagine, for example, a longer Python script does not produce the expected results. Then it would be good to know where exactly the error happens. By printing the intermediate results, this can be found out. In this workshop, we will present two possibilities for this purpose. The first one is the GeoDict-specific function. It starts with the GD and then msg box, which stands for message box, and then inside of the round braces, enter the output. In this case, it will be a string. Strings are always marked with quotation marks, either single quotes or double quotes. Only make sure to use the same quote possibility for starting and ending the string, and then inside the quotes, we enter the string Hello World. This function will open a message dialog displaying Hello World and an OK button to close the dialog. You can also output integers like 42. So we can output most basic Python values, like for example strings, integers, and floating points. The second possibility for text output I will show you is a Python command, which is called print. The content again must be defined within the braces, and this content will be printed to the console of GeoDict. So here, again, we will print Hello World. Again, make sure that you have quotation marks in the font and the end. Click Save and open the macro execution control again. Click Refresh and the new file output appears. Highlight it, and as it has no variable section, the parameter button is grayed out. And because it contains Python commands beyond the normal GeoDict commands, no preview is displayed. Click on Run, and when the first message box appears, click inside the box to stop the countdown, because at the end of the countdown the box would be closed automatically. Here we see our string Hello World. Clicking OK closes the message and lets the new message appear, which is 42. Click OK again. Whereas the message boxes appear automatically, the output from the print command can be found in the console of GeoDict. Therefore, below the visualization area, unfold the console by clicking on the double arrow here. And here you can see the two message boxes, which is always in these 3 lines here. And in the last line, before the finished macro execution line, you find the output of the print command. So if you want to have text output, but do not want to interrupt the macro execution with message dialogues, the print command would be preferable. The next thing I will show you is how variables not defined in the variables section work in Python. Therefore, we open a new file again in the text editor. File, New. Then we will save this file as variables.py. So make sure to save it as Python file and inside your project folder. And now any type of data can be stored into a variable. We had the example earlier of defining a parameter called GDSVP, and all the parameters declared like this automatically appear as a Python variable in your macro. They will have the value given in the user interface. But variables can also be defined wherever it is needed in the script. We only need a name and some value. Of course, then they do not appear in the user interface, but that is not necessary for every variable. We also had the example of a variable of this type before. The Python dictionary, where the parameters for the fiber generation were stored, was also assigned to a variable, and this was called createArgs1. This was needed to execute the actual command for the fiber structure generation. So a variable is defined in the moment it is first assigned. For example, if we call a variable a and then assign the value 42 with the equal sign, then from now on a is 42. We can also show it with the message box. So now we only have to write GD MSG box. And so now we only have to write the name of the variable inside the braces. Then in the message dialog, 42 will be displayed. Also, arithmetic works as you would expect. So, for example, if we call the second variable b and assign the value a plus 1, then from now on b will be 43. So we can also show the value of b in a message box. GD MSG box b. Also, the value of a variable can be replaced by a new value. So if you assign a new value to a, then from now on a will be another value. But for the assigning process, you can also use the old a. For example, a times 2. Then here on the right side, a is still the 42, but from now on, a will be 84. We will also output this in the message box. GD MSG box, and inside the braces a. The last variable will be a string. We call it s, and we assign our hello world string to it, and of course we will also output this. GD MSG box s. Click Save and open the macro execution control again. Click Refresh. Highlight it. It has again no preview and no parameters button like the output pie. So let's click Run. And here we see our first message box displaying 42, which was the variable a. Then the next message is 43, meaning b. And here we have our new a, which is 84. And finally, the hello world string from our string variable. The last Python basic that we will discuss in an extra file are string operations. Again, Back in the text editor, open a new file. File, New. Then we will save this file as strings.py and make sure to save it in your project folder and really as a Python file. First of all, different strings can be concatenated by simply adding them. So let's introduce variable s, and then we will start with the string hello, and then by using a plus, we concatenate it to another string, which will be space world. Then we will output it again with the GD MSG box, and this will lead to our previous string example, hello world. The next thing about strings I will show you is adding variable values into a string. Therefore, first define some integer and float variables. For example, a is 42 again, b is 3.456, and c is 2.65 e minus 14. So this means 2.65 times 10 to the power of minus 14, which is a very small number. So now we define the string as 1, and we will start with the string format f, because this allows to input variable values and curly brackets in the string. So start with an f in front of the string, then write, for example, value of a is curly bracket, and in the curly brackets add a, comma, value of b is b, again curly brackets, and value of c is c, again curly brackets of course. And when we output this with the GD MSG box, the text value of a is 42, value of b is 3.456, and value of c is 2.65 e minus 14 will be displayed. So GD MSG box S1. And we can also control how many decimal places are shown in the string. So call the new string S2, and remember starting with an F. Then inside the quotation marks, write b is, then in curly brackets, b colon dot 2f. This means the value of b with only 2 decimal places, what is 3.46. For c, it would display 0.00, as the e notation means 2.65 times 10 to the power of minus 14, which is a very small number, with 2 as the 14th decimal place. Thus, we will use another formatting for c. So go on with, and c is, curly brackets, c colon dot 1e, and this will lead to c as it is, but with only 1 decimal place, meaning 2.7 e minus 14. So also output S2 with the GD MSG box S2. Then click Save. Open the macro execution control again. Click Refresh. Highlight Strings. Click Run. And now we see the concatenated string Hello World. And click OK. And we see S1. Value of A is 42. Value of B is 3.456. And value of C is 2.65 e minus 14. And finally S2. B is 3.46 and C is 2.7 e minus 40. Now, using this knowledge about strings, we want to take care of the issue that in our parameter study, all structures were saved under the same name, fiber GeoDDR. We had to rename it for each generation, which is very inefficient. Our goal is to make the parameter value of the result file name. So we will find the file name in the parameters dictionary. Therefore, move back to our workshop 2. And then we look into the parameter dictionary, GeoDict1, for the key result file name. Here we have the result file name fibergeo.gdr, of course as a string. And to achieve our goal, we start with an f in front of our string, as we did before in the strings.py. And now, as we vary the solid volume percentage in our parameter study, we want to add the value of the variable gdsvp in the result file name. Therefore, before the file ending, add underscore and in curly brackets gdsvp. The underscore simply puts more focus on the variable value optically. Thus, the string varies with the values for gdsvp. Click on Save. Open the macro execution control again and highlight Workshop 2. Click on Parameters and make sure you have still the value list 10, 40, 70. Click OK and run. Now we do not have to rename anything. Look at the project folder and see the new generated files with the underscore notation. The 3 new result files and result folders automatically containing the SVP value. Now we want to add a second variable to Workshop 2. The goal would be to use vary macro to create structures not only with different solid volume percentage, but also with varying fiber diameters. Therefore, save Workshop 2 as Workshop 3, File, Save As, change it to Workshop 3, and make sure it will be saved as a Python file and in the project folder. Then scroll right to the top of the macro. And first of all, in the description, add vary the parameters solid volume percentage and fiber diameter. Afterwards, in the variables section, change the number of variables in the first line from 1 to 2. Then copy the complete dictionary for variable 1 to paste it below. Therefore, make sure to mark the complete subdictionary with the ending curly bracket, but not the last one, as this belongs to the complete variables dictionary. And it must stay at the end, marking the end of this dictionary. So, copy variable 1 and insert it right below the ending curly bracket of variable 1, but before the last curly bracket from the variables dictionary. Change variable 1 to variable 2. Then we also need a new name for the second variable. So let's call it gd_fd for fiber diameter. And the label we change to fiber diameter. It is still a floating point value, so double for type is okay. The unit, of course, will not be percent, but micrometer. For tooltip, we enter fiber diameter of material 1, because the fiber structure we generate consists of 2 fiber types, and one is assigned to material 1 and the other is assigned to material 2. We only want to change the diameter of the first fiber type. For a built-in default value, we enter 10 microns and we just delete the check line. Again, we have to give this variable some impact. Therefore, scroll down to the GeoDict1 dictionary, and the 2 fiber types are defined in the generator 1 and generator 2 sections. And as already said, we only will change fiber type 1. And here in the generator 1 subdictionary, we find some information about the material, which is glass, the probability of generating this fiber type, which is 50%, meaning 50% of the generated fibers will be of type 1. And then here we see the type is infinite circular fiber. And afterwards we find the diameter distribution. It is set to constant, meaning all fibers of fiber type 1 will have the same diameter. For the value, now we will insert our new variable. We place the 1e-5 by GD underscore FD times 1e-6, transforming the micrometer value in meter, as the FiberGeo commands expects the value given in meter. Of course, now we directly change our result file name. So look for the key result file name again. And here add underscore curly brackets GDFD to make also the second variable a part of the result file name. Click Save and move to the macro execution control, where we will see the benefits of adding a second variable. Click Refresh to make Workshop 3 appear. Highlight it and make sure Vary is still checked and click on Parameters. Here we now see our second variable, the fiber diameter. Hover over the name and see our tooltip. And now for solid volume percentage, enter again 10, 40, 70, and for fiber diameter enter 10, 20, 30. When running the parameter study, the macro will be executed once for all combinations of values from the two lists. So click OK and run, and the macro is executed 3 times 3. That means 9 times to generate a fiber structure for each value combination. And here on this workshop slide, you can see a 2D image for all 9 combinations. As we had 3 values for both variables, the result is 3 times 3, so 9 different structures. And here, the SVP grows from top to bottom, and the fiber diameter increases from left to right. Thus, the structures become denser from top to bottom, and the fibers thicker from left to right. All structures were generated with the same random seed, so they have a somehow similar structure with this one fiber in the upper left corner and the 2 fibers in the middle, and thus we can directly compare single fibers growing thicker from left to right, for example, this one fiber here in the upper left corner, and also the number of fibers increases from top to bottom to reach the given solid volume percentage. So next, look into your project folder, and you find 9 files and 9 new folders, all with 2 variable values in the name. And in the next step, we want to couple our variables, and then we wouldn't see the effect here in the result folder. That's why we will delete all these 9 result files and result folders, because they can be reproduced whenever we need it, so it is no problem to delete them. So here now all the folders with the 2 variable values, and now also all the corresponding result files, and simply delete them. Now go back to the macro execution control, click Parameters for Workshop 3, and we have here the variation pull-down menus for both variables here on the right. And with these we can couple certain variables of the same number of values given for these 2 variables. Here, for example, we see that we can couple the solid volume percentage with fiber diameter or the other way around, which will make no difference. So just select solid volume percentage for fiber diameter. Then the macro will be executed for the pairs 10% solid volume percentage and 10 micron fiber diameter, then 40%, 20 micrometers, and finally 70% solid volume percentage and 30 microns. So just click OK and run. And if we now again look into the project folder, we see that only 3 result files and result folders were generated, corresponding to the parameters we entered in the parameters dialog. This we can also see on this slide, showing a 2D visualization of the results. In contrast to the previous macro execution, now only 3 of 9 parameter combinations were generated, which we can see here in the diagonal. This is because only the value pairs were used instead of the cross product. So this is the end of part 2. We have seen some language basics as 2 types of text output, and we have seen variables and string operations, and also we added a second variable to our macro. Finally, we did parameter studies with the different parameter combinations. Now it's time for another 10-minute break, which gives us time to answer your questions.